Okay, I'm going to try to make this video pretty quick because we're going to look at some basic graphing of a linear equation in slope-intercept form. And so the first thing is a linear equation um, means variables are raised to the first power, basically. Okay, and so slope-intercept form is this form of an equation in two variables, y equals some number m times the variable x plus some number b. All right. And so y and x here are the variables. And so when you've got an equation that has two variables, you can see, by the way, that these are both raised to the first power. So this is linear. When you have an equation with two variables, that means you're able to graph it in two dimensions. And you can also graph it in higher dimensions, 3 dimensions, etc. But we're going to look at 2 dimensions to graph equations in two variables. So let's do some examples here. And by the way, I strongly recommend having some graph paper on hand, just in general when you're doing graphing. So if you don't, that's okay, just draw it by hand. But let me change my paper to graph paper real quick. Okay, so let's graph, and I'm going to show you a couple different ways to do this. Let's graph the equation y equals 2x plus 3. So we haven't talked about what m and b are just yet. We will shortly, but I'll go ahead and identify m as being 2 and b as being positive 3. So m is always what's next to x. Notice that y is by itself. It's important that it's in the proper form. But let's say we didn't know anything about this and we just wanted to graph it. Well, a simple way to graph this would be, anytime you want to graph anything, a simple way to get a feel for it is to create a table of x values and y values, a table of ordered pairs that make the equation true. So an easy way to do that is to plug in points. Like I could plug in 0 for x. Well, if x is 0, then y is 2 times 0, which is 0, plus 3. So y would be 3. And so on a graph, let me create a graph over here. And anytime you're drawing a graph by hand, it's important to label your scale. So in this case, I'm going to use each grid is 1 unit. So 1, 2, 3, 4. I'll label this as 5. I'll label all the 5s so that my scale is known. I could have gone to 10s also, but this is enough to get us going. And now I'll plot the point where x is 0, y is 3 is up here. And since this is linear, I know it's going to be a line, so I really only need 2 points. So let's find another point. I could plug in 1 for x, that'd be fine. Let's plug in, I don't know, let's plug in 3 for x. If x is 3, then y would be 2 times 3 is 6, plus 3 is 9. So the ordered pair 3, 9. X is 1, 2, 3. Y is 1, 2, 3, 4, 5, 6, 7, 8, 9. And now I've got enough points to draw the line. I know it's a line because it's a linear equation. And so our graph looks something like this. Now, this point plotting idea is useful to know, but that's not what we're going to focus on in this video. Instead, we're going to focus on how to do it using m and b. That's the idea, how to capitalize on this slope-intercept form. So m is what we call the slope of the line, and b is the y-intercept. So the way you do this is you first look at your y-intercept, which is 3. Really, it's the ordered pair 0, 3. It's where it touches the y-axis. So 0, 3 is right here. So that's where that's how b is used in the mx plus b. And then our slope, m, you always want to think of your slope as a fraction if it's not 1 already. So I'll think of 2 maybe as being 2 over 1. and that's rise over run. So the 2 represents how much you go up and down, the 1 represents how much you go left and right. So if I start at the y-intercept of 3, and I rise 2, and I run 1, then that gives me this point right here. And I can rise 1, 2, and run 1 again, and that gives me another point on the line. If I rise 2 and run 1, it gives us the point we found earlier, 3, 9. So you can use your y-intercept and your slope to generate points on a graph. You could also rise -2 and run -1 over and over again. So that's how you use your slope and y-intercept. That's why it's called slope-intercept form of a linear equation. Let's try a couple more. Let's try to graph y equals -1/2 x minus 4. So here, -1/2, this is our rise. Positive 2 is our run, and our y-intercept is the ordered pair 0, -4. By the way, if you ever want to find a y-intercept, just plug in 0 for x, and then find what y is. So again, I'm going to use scale of 1, so I'm going to label my axes. So I'm going to start with a y-intercept of 0, -4, so 1, 2, 3, 4. And then I'm going to rise -1 and run +2. So down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. I could go up 1 and left 2. That would work as well. And generate as many points on this line as I want. But there is the line for this equation. Let's do another. Let's graph y equals 4/3 x. I'll set up my grid. And in this case, we don't have a plus b, so we could think of it as +0. So we have a y-intercept when x is 0, y is 0. And you could check that by plugging 0 in for x and finding what y is. And then our slope is a rise of 4 and a run of 3. So 0, 0, and then I'll rise 1, 2, 3, 4, and run 1, 2, 3. And I could do more points if I wanted, but it's going to give me this line. And it's that simple. So sometimes you don't have a b, so think of it as 0. Let's do one more example. Let's graph y equals 4. And in this case, there's no x, so we could think of this as y equals 0x plus 4. That's because 0 times x is 0, and 0 plus 4 is 4. That's one way to do this. Let me set up my grid. So I've got a y-intercept. When x is 0, y is 4. And our slope is 0. I want to think about that as a fraction. I could think of it as 0 over 1, or really 0 over anything. So I'm going to plot my y-intercept, 1, 2, 3, 4. I'm going to rise 0, so I'm not going to move up or down at all, and I'm going to run 1. Rise 0, 1, run 1, rise 0, 1, run. And what you see is when you have a 0 slope, you get a horizontal line. Now in practice, nobody graphs y equals 4 in this way, but you could. What most people will do is say, oh, y is 4, so it crosses the y-axis at 4. It's a horizontal line crossing the y-axis at 4. And that is it. That's graphing lines in slope-intercept form.